Abdulrahman, the Dean of the College of Computer Science and the Supervisor of the Saudi Aramco Cybersecurity Chair. And would like to thank you for sharing your experience today in very important topic of zero trust architecture and model. And we are looking forward to have your experience shared with our audience today. We have among our audience, we have students, faculty members, and also employees from Saudi Aramco and different companies. And looking forward to know more about the topic. And thanks again for accepting our invitation.
Sure, thank you. Thank you for inviting me.
I think we can start now. I can see a good number of participants. So good evening, everyone, and good morning, Scott. I know it's early morning on your side. It's my pleasure to welcome you all in our monthly seminar arranged by Saudi Aramco Cybersecurity Chair at the College of Computer Science and Information Technology at Imam Abdulrahman bin Faisal University. The title for today's seminar is Demystifying Zero Trust. We are lucky to have a pioneer of the zero trust architecture. As we know, zero trust architecture is getting attention and popularity in enterprise IT architecture. However, zero trust is often misunderstood or misapplied. This talk will cover zero trust principles and the National Institute for Standards and Technology, United States of America's work in zero trust and outstanding issues in zero trust adoption. I believe this talk will be of great importance and interest to our participants from academia, industry, and government sectors. My name is Nasr Minallah. I'm a professor at the College of Computer Science and Information Technology at Imam Abdulrahman bin Faisal University, and today I'll be moderating this session. Just a few housekeeping rules for those who are going to join us for the first time before I introduce the guest speaker. The format of this talk will be divided into two parts. The first part, the speaker will present the work, followed by a Q&A session. You can type the question in the chat window, and I'll be glad to speak out your questions to the speaker at the end of the Q&A session. At the end, we would also like to have your feedback on how we can improve this seminar series. For this matter, in the chat window, we will share a link with you, so kindly consider it as a request from our side. And all the participants who will be attending this talk will be receiving the certificates signed by the Saudi Aramco chair. Now let me introduce our guest speaker, Scott Rose. Scott works as a computer scientist at the National Institute for Standards and Technology, United States of America. Scott works on Internet infrastructure protection, research, and Internet protocol research. Scott is the editor of several Internet Engineering Task Force network protocol specifications and the author of several NIST special publications on secure Internet protocols. His work is in bringing zero trust security understanding to the US government. Scott received his BA in computer science from the College of Worcester and the MS from the University of Maryland, Baltimore County. Scott is an authority on the zero trust architecture, and we are really glad to have him today. Especially, I'm very thankful for his time and his commitment. I hope his talk will help us all to have get more experience and interest in the zero trust. Scott has a rich experience of implementing the zero trust architecture and framework. With this, now I will ask you all to please join me in welcoming Scott Rose. Scott, you may take it from here, please. Thank you.
All right, thank you. Yes, it's an honor to be here. Since we started this work, I haven't actually done a lot of international presentations, which is odd in this day and age when everything can be webcast. So this is kind of a new opportunity for me. But here, let me start my slides.
It's mute.
There we go. Yes, it was muted.
Yes, now loud and clear.
All right. Okay, so yeah, sorry about that. Strangely, it's kind of one of the few zero trust actual work that we do here at NIST, or configurations here at NIST, is we actually there was a policy to disallow Zoom, and so quite frequently in an enterprise management tool would actually come through on all enterprise-owned laptops and delete Zoom if it actually sees it, and then causing you to have to re-download it every time. But hopefully everything works, and now we can get started. I said before, yes, my name is Scott Rose. I'm a computer scientist currently in the Communications Technology Lab here at NIST. NIST is part of the Department of Commerce, so we actually are not part of the Department of Defense or the national security kind of industry or portion of the U.S. government. We deal more usually with industry, helping U.S. industry, as well as helping. One of our roles is to help the civilian side of the U.S. government when it comes to cybersecurity guidance and recommendations. So moving ahead, we'll talk about today is zero trust. Basically, first I'm going to kind of define what we mean when we talk about zero trust, or what we're talking about when we talk about when NIST is talking about it, and kind of what we're doing both for the federal government and for kind of larger cybersecurity community. And from that, we'll talk about the NIST special publication 800-207, that's zero trust architecture. And that's kind of a conceptual framework document that we kind of wrote up to kind of help describe zero trust and these zero trust principles, and kind of aid federal administrators as well as private industry, because it's kind of applicable to all, to kind of understand what we mean when we're talking about zero trust, and kind of help them kind of develop their own architectures and to move to more to the zero trust posture. And since this is kind of a university, I've included some kind of open areas. What I see in zero trust, or kind of where I see is like kind of the cutting edge, both kind of some of what we're looking at, and kind of like some open areas that haven't been fully explored. And then kind of what's some of the things that we're trying to explore at what we're calling it's the National Cybersecurity Center of Excellence. We're calling it the Implementing a Zero Trust Architecture project. That's kind of a follow-on project, taking some of the concepts and ideas from the NIST special publication and putting it into a lab environment with some vendor partners, so bringing in their products and things like that. And then, of course, the Q&A. So first off, when we talk about zero trust, because it has a very long history, going back from about 2007 at least, the Department of Defense Information Systems Agency or DISA had what they called the Black Core project. And what they started to do was thinking they wanted all the traffic going through the core network to be encrypted and be completely opaque. So there's no third party could be sniffing traffic or altering traffic. Only the endpoints can see what the communication were. And that kind of evolved into kind of like the Jericho framework with the deperimeterization, where they said let's focus on network boundary defense and focus more on endpoint defense, and treat the network as always either compromised or contested is probably a better word, and that there could be an active attacker on the network. You always have to assume that is happening. So any security posture that you would have for an internet-facing service or endpoint, you would almost want that exact same posture and protections architecture for internal resources as well, because you shouldn't be able to trust your own internal infrastructure just because you own it. You have to assume that there could be a breach. For example, in this case, there's a famous one a few years ago where in a casino in the United States had a Internet of Things thermometer on a fish tank, monitoring the temperature and various other factors for this fish tank, but had a vulnerability, and attackers were able to compromise that and actually get a foothold. And since that IoT thermometer was connected to the corporate network, they then were able to actually move laterally into the corporate network of the casino and eventually perform a ransomware attack and kind of encrypt some of the vital business data of that casino. And that's what zero trust is basically trying to prevent. That kind of, we're knowing those initial compromises are bound to happen, phishing attacks happen, things like that, 0 days. But the idea is we're going to prevent that lateral movement. So just because it's in the corporate infrastructure or corporate network, it won't be able to further compromise. And that's kind of what we see here on the bottom here diagram. You have kind of a traditional like an endpoint, a requesting endpoint, and it's going through that untrusted zone. So that means, it could be the internet, could be the corporate LAN, and it has to go through a policy enforcement point and also a policy decision point where it says it's checking the authorization, the authentication, potentially checking the compliance status or the health of the endpoint that's making the request. It's checking the network identity. It's actually looking at environmental factors, what time of day, what IP address is it coming from, things like that. And then once all those checks pass, and if it's successful, it goes into this implicit trust zone where it's now trusted in effect, because now it can access the resource. And the whole goal of zero trust is we want to shrink that implicit trust zone to kind of ideally just encompass that single resource. So just because you can get to one resource doesn't necessarily mean you can get to another resource on the corporate infrastructure or even in the cloud or anything else without also going through yet another policy enforcement point and the decision points that you're doing all those checks again. Yeah, so you're making a check for every kind of request for a session. And to that point, like I said, zero trust isn't a single technology or a protocol or even a single architecture. We kind of always use the term, it's a set of principles used to kind of when creating and implementing and operating an infrastructure, an IT infrastructure. And that could be anywhere, on-prem, cloud, it doesn't matter. We got like 7 principles we're calling the tenets of zero trust. I'm not going to list them here because it's a big wall of text, and that's actually in the guide if you're interested, and there's the link at the bottom. But they kind of fall down into like 3 broad categories. 2 that kind of work around the user, kind of user-centric, and that's, authentication is dynamic and strictly enforced. That's your multi-factor, and is granted per session, which means just because I open up a session to one web app, for instance, in my corporate enterprise does not, I have to go again and do the same sort of checks and procedures to access a second resource. It may be kind of invisible a lot to the user, it may be always being prompted, but the idea is those checks are continual. It's not a guarantee that just because you access to one resource, you get access to all of them. There's a couple that are device-centric, so all systems are considered resources. And this one's a little different than some of the other principles that you may have encountered, things like Beyond Corp, Forrester. I think the UK government has their own set of principles. A lot of them are focused either on data or a resource or like an enterprise asset or something like that. And we're calling all things are potentially resources. That includes your data, that includes IT, IoT, and OT kind of sensors and actuators. Sometimes those are kind of left behind in a lot of this architecture planning. But the idea is that you need to kind of consider all of those things. And also, these devices are kind of constantly maintained in the most secure state possible. It's not to say that you're constantly preventing all attacks, or you always have the latest and greatest patching, things like that. But although that may be part of the security posture the enterprise wants, but the idea is that each of these endpoints and resources, both the requesting and the ones hosting the data or resource or service, all of those are kind of constantly being monitored and checked and improved and reconfigured if new security vulnerabilities or new intelligence is gathered. So any kind of dynamic changes are dynamic and kind of enforced quickly. And the last ones are kind of data centric. Again, all communication is secured. That's all traffic is encrypted. You want to use an encrypted version of all the protocols. That may not be possible with all things. You got to think things like, especially old ones like DNS and a lot of legacy systems, they can't do that. Then you have to look for kind of mitigating controls. And there are some even for DNS as well. Logs are used to refine policy, both in kind of threat intelligence, but also access patterns, behavior, things like that. All those kind of things are analyzed and then fed back into the system to kind of refine that security posture. And so if changes are detected, that can be immediately kind of raised to a human administrator to see if this is an active attack or something just changed and like kind of the policies need to be further refined. That's kind of one of the real aspects of zero trust, is that it is very dynamic and there is kind of this feedback loop of, as the enterprise is constantly being monitored, those logs and activity is then used to further refine the policies. And lastly, kind of default deny. That's kind of the thing where, just because, in the old days, every endpoint can contact any other endpoint on the network. But it doesn't need to. For its usual business, for business processes or workflows, you have no business reaching maybe 90% of that, the other endpoints on the network. And the idea is that it should be a blanket deny with exceptions granted only for those resources that are needed to perform the workflow, and only after being authenticated and compliance checked and all those kind of tests. In other words, actually, once you go through a PEP, or policy enforcement point, you can then continue on to the resource. And one slightly difference thing in a lot of these principles that kind of differ from ours is, even though, yes, we say all traffic is encrypted in rest and in transit, it does not mean that there's a single person who is able to read all that traffic. There are some versions of these principles that say like all traffic is inspected by the enterprise somewhere and then logged, and you do deep packet inspection in order to try and detect attacks and things like that. We're making the concession in our kind of conceptual framework that may not be possible or even desired. You may have instances where you may be handling sensitive data. For instance, in the US, there are regulations specific to health care related information or security related information. And the people seeing that data or traffic would have to be specially trained and certified to handle it in an unencrypted form. So the idea is you may not want your administrators, your network administrators, to see healthcare related information. So that may actually be encrypted, and they may actually they might be able to fully kind of perform inspection on that traffic. But there are other kind of steps kind of ongoing. There's kind of some machine learning work going on to kind of characterize those kind of traffic to show standard traffic from potentially malicious traffic. So even though if you can't inspect the actual data going by, you can get a feel to see whether or not an actual encrypted traffic stream is malicious or not. Moving on, this is kind of the main diagram that's used for us in the guide to kind of describe zero trust, kind of the functional components as we kind of identify them. Down at the bottom there or in the middle, we separate the network as the kind of more modern views of networking into the control plane and the data plane. The data plane is for application traffic. The control plane is used for the administration of the data plane to kind of set up resources, set up connections and sessions, and tear them down again. And at the bottom, that's kind of like from the original slide, a couple slides back, you have the system. Here we call out the subject or the actual network identity, the user, going through a system, going through that untrusted zone through a policy enforcement point. The policy enforcement point exists in the data plane and a little bit in the control plane because it has to be controlled. But instead, it sends a lot of that requests up to the policy decision point, the PDP. And then there, we kind of break that out into two functional roles, what we're calling the policy engine and the policy administrator. The policy engine, think of that as kind of the brain of the entire of the decision-making process. It's taking all that input, both from the system and from those policy information points on the side, like your data access policy, results of any kind of PKI check that's being used, industrial compliance or the actual data management policies in the organization, threat intelligence and activity logs. All that information is being used by these kind of policy engine role to kind of make a decision. Do I allow this connection, yes or no? And if it's yes, the policy administrator is then charged with setting up that session. So it's actually kind of the session management function. If you think about it that way, it's it sets up whatever's needed, firewall rules or something, or flow control or something like that. If you're doing kind of more of a network flow, in order to set up the connection between the system and the resource. And then it's also charged, the policy administrator is also charged if that decision ever changes from the engine. If the engine decides, no, wait a minute, I'm going to revoke that access, or it fails, the policy administrator's job is also, again, to tear down that session and interrupt it if it's needed. So that's kind of how we're looking at it. And the thing that needs to, I need to stress is that kind of like that policy engine and the policy administrator is not a single component. This is a functional role. It actually could be a single software component, could be performing both of those tasks, the policy engine, policy administrator. You might have multiple policy engines in an infrastructure, looking at different aspects of the authentication and authorization. You could have maybe one doing ID checks, one doing compliance checks, and they're kind of forming kind of a multiple, a hive brain or a system of systems to each individually, check little portions of it and then perform their own little individual tasks of it. But then again, further into the guide, once we kind of lay out those kind of functional roles, we kind of identify, again, to help administrators, kind of approaches that we've seen, both in doing our kind of our research and talking within the vendor community and the cybersecurity community and within agencies of doing kind of approaches and deployment models. The approaches are probably a little bit more interesting in that it's usually where the emphasis is put by the decision makers, the policy engine. There's one, enhanced identity governance. That is where in enterprises or in the architecture, the network identity kind of forms the lead role. Everything is based around that identity. You'll see some claiming that identity is the new perimeter or identity is the new decision-making process. Those are those kind of approaches where everything is tied to kind of a network identity. And are they able to authenticate, and then are they authorized to reach this thing? And second to that, maybe endpoint compliance and things like that. It's not to say that those don't happen. It's just those are taking a lesser role, a supporting role. Next one is kind of a micro segmentation. That is kind of if you think of the network stack, these are ones down at the lower level, sometimes layer 2 or layer 3 solutions. These are very common kind of on an on-prem or on-premises on kind of a network where they have smart switches or firewall rules or something like that kind of handle things at that kind of layer 3, where they're just looking at the individual packets and they're routing traffic either to a resource or not, or blocking traffic to a resource based on what the signals are from the policy administrator and policy engine. So, the authentication is happening, but the actual administrator, then the policy administrator then reaches down into kind of these individual smart switches and actually sets up the actual traffic flow between the endpoint and the resource. And then the third one is kind of what we're calling software-defined perimeter. This is kind of a higher level at the network stack, usually at 6 or 7, mostly at time at 7. And this is also a lot more common in cloud kind of instances because there is no, that isn't really, the infrastructure isn't owned usually by the enterprise. And these are a lot of like your CASB solutions, things that take, that may have like a portal or an agent based on the endpoint that you then takes the authentication credentials and then goes to some sort of cloud-based network controller that then has like an overlay network that then allows you to access kind of like the resources or something like that. And all these are just, they're individual, approaches to zero trust. And sometimes multiple ones may appear in a single enterprise. For instance, like, there may be a micro segmentation in on-prem or on the campus, but for remote workers or, mobile devices, they have kind of a software-defined perimeter or CASB solution installed. And that's what they're using for mobile devices to reach cloud-based resources or things like that. So it doesn't necessarily mean that one has to be chosen. It actually could be multiple. And then, to help kind of administrators think of models, kind of deployment patterns, we just, identified the main ones. Like I said, there's kind of like the agent gateway. Again, that's kind of very common in these CASB solutions where there's an agent residing on the endpoint, some sort of tool. And then there, like a similar one is actually on the resource side, acting as kind of like a reverse proxy. It's kind of like the gateway, and it's protecting, it's standing right in front of the resource. Portals, which are kind of like the same thing as an agent gateway, only there's no agent involved, and it's some sort of like web portal that the endpoint has to go through and the user has to authenticate to. And then lastly, there's kind of like an app sandbox, where individual applications are kind of segmented away on the endpoint and things like that. These are just different kind of models that we've seen kind of in some of the vendor solutions when we've talked to them of kind of how they do zero trust or how they're implementing some of these zero trust principles. But then some open issues, kind of moving forward to kind of what is the cutting edge. And like I said, one of them is, zero trust, at least right now, is going to be, in reality, is going to be a complex system, kind of like the system of systems. You're going to have multiple policy engines. You're going to have an ICAM system, which is acting as the policy engine for authentication of network identities. You may have some sort of endpoint solution that's acting as a policy engine for device compliance and device health. And all these have to talk to each other. You may have one that does data. You may have one that does the network monitoring. And all these may have override decisions over everybody else. In other words, they all have to pass their own individual checks before that session is granted. But each one may have individually have like a veto power and may be able to block that connection. And then so like the work is, how do all these various components work together? How do they talk to maybe a central data repository so you can figure out what happens when something goes wrong? Because if sessions are granted, everything's fine and everybody can do their work. But if one of them has a problem, what happens? How do the administrators know what happens to that endpoint? If it's something, if the endpoint is wrong, does it have to go into a quarantine zone until it's patched? If it's the authentication that's wrong, what happens? Is all the network credentials pulled for that account? So there's a lot of work kind of going on as to like how you get all these kind of heterogeneous systems to kind of work together into kind of a unified policy engine, kind of a meta policy engine. Again, IoT, especially low power devices, right now they don't work well in kind of a lot of zero trust because they don't have real identities. There's no user interface, so they can't have a network identity. They can't do multi-factor authentication. They could have, some of them may be expensive enough to have kind of a hardware root of trust, and they can maybe have some sort of identity certificate or something like that. How do these all work right now? The most common solution is to just kind of segment the entire IoT or OT deployment away. But then, there has to be an IT component that controls that. And so there always is going to be a linkage. And that's, if you look at something like Colonial Pipeline that happened here in the United States, the IT systems were compromised, but there were links between the IT system and the OT. So as a result, they had to shut down their operations because the IT system couldn't control it. One of the things that's going on right now, you can kind of see some of it going on, is like the attacker reactions to kind of zero trust. As zero trust is meant to kind of stop this kind of lateral movement and enforce authentication. Attackers are going to have to adjust. And so we're, right now, you guess you're kind of seeing some work being done in like supply chain security, because they realize if they can't attack the actual points, maybe they can move upstream in the supply chain and kind of compromise the actual implementations. So by the time it gets installed, they've actually got a foothold, already kind of installed when it gets turned on. Something like SolarWinds, you're seeing some work in the kind of like the hardware security, kind of breaking into roots of trust for like stolen laptops and things like that. So as kind of like these new zero trust components and architectures are getting rolled out, you're going to have to see attackers kind of adapting, because they're going to want to continue to perform their criminal activity or whatever. So you're going to have to, so there's some work of, how exactly are they going to respond? And on the flip side of that is kind of the user experience. There hasn't been a lot of work looking at kind of the end user and administrator experience to this. And that's actually kind of two different things. There is kind of been work going on into what we're calling security fatigue, or where the end users get tired of constantly having to put in kind of a password or a PIN, or having to constantly receive text messages or some other on like a phone to kind of enter in that PIN. How much of that can you add to a process, into a business process or a workflow before users kind of get tired of it and stop maybe being as productive, or kind of getting fed up and trying to find ways around it. And then you get the shadow IT problem in an enterprise, where there's a corporate data being hosted on systems that aren't enrolled in the asset management, that aren't being patched and things like that. And on the other side, you got the administrator work. They're the ones kind of monitoring and performing a lot of the actions in setting up this system. But as zero trust is very dynamic, it's putting a lot of stress on humans, so much that a lot of automation is going to be assumed. You're going to have there's a lot of work going on in behavior analytics and machine learning algorithms that'll automatically make decisions and roll out new configuration changes to the network as in real time. And as there's not a lot of trust in some administrators into these kind of machine learning processes because it is kind of opaque. Again, there's not a whole lot of visibility. There's a lot of work going on into this kind of visibility into machine learning algorithms. But you're kind of putting a lot of your trust in that. And so administrators are kind of trusting, ironically, kind of this automated process, kind of an AI, running their network. But again, they're the ones responsible ultimately. So there hasn't been a whole lot of work, kind of in the human factor of administrators saying, how willing are they to, or how much control are they willing to give up in order to an AI system or to a machine learning algorithm to respond and make changes to the infrastructure. Again, but also kind of on a higher end, kind of those are more researchy, but more kind of on the development side, kind of closer. We've seen a lot of gaps in interoperability. I mean, there's some cases kind of moving away from some places to kind of like these open protocols and standards, kind of from like an IETF or W3C, to kind of the industry consortiums and groups of companies, partnerships using standardized APIs. Now, an API, could be standardized and could be considered like kind of an open API or something like that. But some of them aren't, and some of them are being, dictated by the largest player. And if the largest player makes a change to the API, suddenly the former partners are no longer, interoperable, and there's a risk of this kind of vendor lock-in, where especially a lot of enterprises and a lot of federal agencies are kind of hesitant to make the plunge to a single vendor, knowing that they're going to be trapped in that kind of constellation of that vendor and their partners, and they're never going to be able to make a change. And they're not going to be able to maybe buy a better component to do one sector of zero trust, like endpoint compliance or something like that, because it's not a vendor partner and it doesn't work with what they have. So interoperability becomes the big thing, especially in larger enterprises. Again, IoT solutions, not so much resources, but protocols and standards are kind of being developed to look at maybe if you can't do full zero trust, what can you do? Can you do things like that provide you some sort of a unique identifier of devices? If you can't do transport security over multiple kind of transport mechanisms like wireless or LoRa or 5G or something like that, could instead there be an end-to-end data security where the actual message is then encrypted and passed along. So instead of doing end-to-end transport, you're doing hop by hop, but it is fully end-to-end because the message is encrypted. Something like that. Those kind of standards are kind of rolling out and being worked on. And again, for the user experience, lastly, there's a lot of work on how you educate help desk people into how do you quickly diagnose kind of these problems, because the end users now, some of these solutions are completely opaque, especially like a micro-segmentation. Everything is kind of invisible to the user. It's happening down at layer 3. How do they quickly determine what's going on? But for some of these things, like I said, the National Cybersecurity Center of Excellence, there is the project called Implementing a Zero Trust Architecture. They're calling these building block projects, and how the enterprise or how the NCCOE works is they issue this kind of this project description, and that's it on the right there. That lists kind of a list of capabilities and scenarios and use cases that they want to investigate. And then they have a call for participants, and then kind of private industry vendors then submit kind of a letter of interest, what's called, basically saying, I want to participate and I will bring these kind of components that I produce. And they meet these requirements and I'll show you, and I'm willing to donate them and work with you and things like that. And so all these vendors then are brought together, kind of a cooperative agreement is reached and signed saying we're going to do this project together. And then they do what they call a series of builds, which for this project is basically a mock enterprise infrastructure. So they'll have some network segments, they'll have resources, they'll have endpoints, mobile endpoints, they'll have some user network identities that they create. And then the idea is that these network identities are then going to try to access the resources either on-prem or on a remote location, kind of dialing in, or well, that's the old way of saying it. But basically, a remote mobile worker trying to reach resources located on the corporate infrastructure or in the cloud or something like that. These kind of various use cases that are kind of common to corporate workflows. showing how the zero trust architecture meets the security requirements laid out in the project description. And then it's all written up in another special publication series as kind of a demonstration guide. And the one difference of this NIST SP 1800 series, as they're called, as their number designation, is that these are a lot more practical than an 800 series. An 800 series, like 800-207 or anything like that, will just kind of describe, it's a conceptual framework kind of document. It's more descriptive. These 1800 series documents are a lot more practical, and they will actually feature an entire volume at the end, written with the vendors to describe how it was set up, the actual product, the actual steps taken, screenshots, configuration options, things like that were taken in the lab in order to develop the build used for the demonstration. So it's a lot more of a how-to guide than the 800 series. And lastly, I always get asked these kind of questions, but I'll start right now. Is like, where do you start? The biggest thing is you start with the people. The idea is that you have to know what is going on in the infrastructure and the architecture and what the business is. You have to identify what are the core mission of the enterprise, what are the business processes, who owns those business processes, and you got to perform kind of a risk analysis. Who in the enterprise reaches what resource at what time. And because you can't protect what you don't know, you can't set policies on what you don't know. So all of that, kind of needs to be known. So it has to be, you have to know the network identities used in the enterprise. You have to know the assets that are owned by the enterprise. You have to know the workflows used by the enterprise. So what are these network identities using what resources reach what other resources? And with that, with that risk analysis, you should be able to identify what some people call them the crown jewels, some people in the government, they're called high value assets. These are kind of the most important resources and important workflows vital to the mission. You think those are usually the ones you want to secure first. So you kind of work from there. But then, kind of the opposite kind of thinking is sometimes it's easier to look at kind of the low hanging fruit. That's kind of what you look at the federal government is sort of doing with kind of the OMB, the Office of Management and Budget, issued a policy on zero trust for all federal agencies, and they called out a set of immediate kind of policies changes to identities, network traffic, asset management, and things like that. But they kind of see as kind of like the initial first steps to get in place, things like multi-factor. Which again is kind of an enhanced identity governance thing, kind of doing more of an endpoint protection for compliance and things like that, and then encrypting traffic everywhere. So they're saying like do these basic steps first, and these are kind of like the low-hanging fruit, and they usually center around identity management. That's usually the easiest because that's more of a software change for the most part, not always. Than it is like say a microsegmentation where you're kind of installing a bunch of smart switches that you may not have, you may need to buy first. And then, of course, the most important thing is after you make every changes, implement a monitoring regime. And how are you going to learn, how this has changed and improved things? You need to actually see what's going on in the enterprise. So you need to have a competent monitoring infrastructure in place, maybe kind of a central logging system connected with a SIEM and things like that. So you can't actually, if you can't monitor what's going on, you really can't protect it. And as always, kind of what I said in the beginning, zero trust is not a single solution. It's not a single technology. It's kind of a process that you're kind of constantly going through and making kind of improvements on the kind of like to kind of like further refine the kind of security posture. So it's not something that can be bought off the shelf or from a single vendor and saying, okay, if I only buy this product and install it on my network, I'll have a zero trust infrastructure. Or single trust architecture. That's unfortunately not how it goes. It's usually kind of an ongoing process of refinement and improvement kind of going on as things change and kind of a technology refreshes happen. So I guess that's it. That's the end of the presentation. The more important thing I think is to kind of have more of a discussion so I can answer some of your questions. And see to kind of help kind of further describe kind of what we're doing here and what we're trying to kind of describe and help people implement and kind of what we're doing for the federal government. stop sharing.
Thanks, Scott, for a very informative seminar. It's interesting to see the birth of Zero Trust in 2007. And I like the punching line that Zero Trust is a process, it's not a single solution. We're looking forward for your more publication by NIST. We have received a number of questions, some through registration process and others through online. Recently, I received a few questions. So maybe I will I will read out some questions, and I will also type the question in the chat window for the participants. Let me read the first question. All right, so the first question says, are these principles typically used individually or in combined hybrid approach?
Ideally, kind of combined, kind of in a hybrid approach. But like I said, since it's usually a process, it's usually kind of individual principles kind of being emphasized in one kind of refresh cycle. Like they're doing one maybe first trying to implement kind of an identity authentication at every session, and then kind of keeping endpoints, and then keeping that, once you've got that done, then start working on the inner one of saying, all my endpoints in the most secure state possible. And once I get that done, am I encrypting all my traffic, that sort of thing. That it's in a real world, those things you can't advance on all fronts at once. And so they kind of, are kind of done in kind of individual steps and kind of a maturity plan where, you try to do one and then the other. The idea is, but once you get one kind of in a state where you've made an improvement, you want to keep that steady and then bring something else up in 10, like maybe doing endpoint protection while you still are doing, identity and an identity governance system and things like that. So, I mean, ideally kind of a hybrid approach. In reality, they tend to be one seems to be emphasis at a time while they're doing kind of an improvement.
Thanks, Scott. So some of the questions you have already clarified these questions that have been discussed in the seminar. But for the sake of asking questions, I think I will ask a few more. The next question says, is Zero Trust a technology that I can simply buy out of the box?
Nope. Unfortunately, no. That's not to say that some vendors are providing a more mature and elaborate system, especially those large vendors that have kind of a whole family of products. They kind of allow they kind of will have a an almost there solution, or at least vital components that can be added. But then again, the idea is you can still actually have these kind of products and components operating in your infrastructure and not use them in kind of a zero trust kind of way. You can think of it that way. You still kind of need to keep those principles in mind when you're doing your planning and initial deployment and things like that, because just because these features are present, they're not always used, or they may not be used in the correct way. For instance, like could have these kind of smart firewalls, but they're not. You're placing them at network boundaries, and then you still have a VPN come in and things like that. That's not really zero trust. Having these kind of smart firewalls, kind of in a micro-segmentation architecture where they're smaller and protecting individual resources, is kind of a more of a zero trust style architecture than kind of a traditional. It could be the same components, just being kind of deployed and used in a different way.
Thanks. So another question you can see in the chat window, it says, how you mentioned the hardware root of trust. As we see companies like NVIDIA and Intel move into this area, can you elaborate more on the technology and the benefit of it?
I can't really describe the technology too much. I'm not a kind of a hardware systems guy. I'm more of a network guy. But I do know what we're using it for, what we like to use it for. You got to think of these as kind of locked away kind of components on hardware that can kind of keep a private key pair or something like that, private portion of a key pair, or some sort of cryptographic material safe, or from having a limited interface to the rest of the systems. The idea is that if an attacker can then breach the system, they can't read those private keys because it's kept secure in kind of a hardware module onto a chip that they can't access through an API. And if they do, it ends up getting, it can get voided out or something. But the idea is that if you have that kind of root of trust or kind of that hardware security module and with a private key, there's kind of there's a standard the 802.1 AR things like that's the IDEV ID cert. These are kind of digital certificates that kind of can be down to an individual component or root of trust on. So the endpoint can have its own identity certificate. It makes it unique. And once the idea is that if you have a unique identifier for IoT devices or endpoints or mobile endpoints, you can actually generate policy around those individual things because you can uniquely identify each one, and you can say, okay, is it in compliance? Is this one device in the right location? Should I allow this resource request going forward from this device in this location? Things like that. Those are kind of powerful because you can make a lot finer grain policy once you can uniquely identify devices. And then again, they can also use that for secure communication. Again, like the message-based encryption or digital signatures that IoT devices could use, and that way they don't have to rely on the underlying transport. So if you think of something like 5G or LoRa, they're doing some sort of radio transmission, then it gets converted at a gateway into an internet packet, and then it goes through to a cloud service. Now that gateway in the middle may not be trusted. It shouldn't, maybe it shouldn't be trusted. Maybe it's a commercial grade carrier or something like that. If you can use your privately held key that only that device has to encrypt or to just digitally sign that message, it can then have trusted end-to-end communication that way, even over an untrusted transport.
Thanks. Yeah, the other question, can the zero trust architecture be described as a closed access control model?
Sort of. I mean, it's you could say that is one model. I've seen some ones that maybe not that way. It's kind of hard to say. It's because we have seen where there are kind of like fault authentications, like it's in that sort of model like that, and kind of a closed authentication. And we've seen other ones where it's kind of temporary roles are assigned to individual accounts that then can perform an action and then lose that privilege as soon as they're done. Then we've seen ones where it's based on a set of attributes that are given at a time. There's no single approach. I hate to say, I guess one kind of that looks like it's often used as kind of a good approach, but in and of itself, I can say it's not exactly pure zero trust, and that you only can do that. There may be other options available out there. I hope that answered the question. I'm not 100% sure about that. I haven't given that a whole lot of thought, I must admit. So yeah. Oh, I see another question.
Yes.
About AI. Yes, the question is how much do you think the appetite for organizations to let AI decide their security policy dynamically? Right now, not much. Well, think of it that way. It's kind of split. I'll see. You'll hear from upper management thinking that's a great idea, because it's automated, it'll be fast. That's great. But then when you start going down the lower levels, the appetite disappears, mainly because they know they're the ones going to be held responsible if a mistake happens that they didn't approve, or they're unsure about whether or not it can actually understand what's going on. That's a lot of data, and there's still a lot of refinement going on. So right now, I'd say no. Administrators want to have some sort of human in the loop. So some of it you'll see like two areas of two paths of research going on. One where the full automation, and another one where there'll maybe these kind of behavior analytics that'll be going not so much in real time, often because it can't do it in real time. But it'll be running kind of like, over a period of time, it'll do a batch and it'll start learning these kind of behaviors of access patterns for network identities and devices. And so when it sees something going off, it'll log a red flag. It'll send an alert to a knock or something like that, or to a help desk or some sort of trouble ticket, or to the SIEM will start collecting data to kind of throw an alert saying, wait a minute, something bad may be happening. And then the human in the loop then kind of, then comes in, does the further investigation, decides whether or not this is an incident that needs to be investigated, or if an exception needs to be made or something like that, or some sort of policy change needs to be made. So ultimately the human is making the decision, but the kind of like the machine learning part is just kind of monitoring behaviors and traffic to determine anomalies. So that kind of anomaly detection is probably going to be seen, being used first before kind of like this full automation happens.
Thanks. The other question says, how can I add zero trust to an ongoing cybersecurity upgrade?
That's kind of like, again, kind of takes the, you need to have kind of the knowledge of what the mission is and what the risk is. Once you have all that in place and perform that, you can start tying kind of this work to kind of a technology refresh. You could say, okay, it's time to maybe we need to start doing more. We've got a lot of mobile users, let's say, for instance, I can say this as an example of what's going on in some agencies. They're moving to providing more mobile devices to users. And so they say, okay, now we have a lot of remote workers with mobile devices accessing cloud. We shouldn't have to have them VPN into the corporate environment, get a corporate prem, IP address issued, and then they go back out to their cloud provider and access the web app that way. Instead, they're looking at something like, why don't we just move to kind of a software-defined perimeter or some sort of CASB solution to get the mobile devices work. And so traditionally, years ago, or a year ago, they may have been using laptops to VPN into the corporate network to then use these web apps. Now, instead, they're refreshing and getting kind of these CASB solutions on mobile devices, and they can go right to the web or right to the cloud instance without having to go through the VPN. So they're kind of tying that to those kind of refresh cycles and things like that. So that's kind of how some agencies are looking at it, for example. But yeah, the idea is that you look for incremental changes when something comes up. So if network hardware starts kind of aging out, and you're going to remove kind of old switches and put in new ones. And if they're kind of like a smart switch, you think, well, can we do some sort of micro segmentation for to isolate some of the resources away from the rest of the corporate network, and kind of build out from there. I mean, the idea is that you're constantly making these kind of little incremental changes as things are getting replaced and kind of improving kind of this overall security posture.
Thanks, Scott. The next question is, what is the main problem with the zero trust architecture?
See, the main problem is will probably be there's a steep learning curve, and your risk analysis may be bad. That's the first step. If you make a step in that, if you make an error there, it'll just propagate as it goes on because you're building under a false assumption. That's kind of that's kind of the bad thing of where you're like when they first so a lot of these products, for instance, they kind of realize that, and a lot of the vendors will have kind of like what they call like a monitor only kind of operational posture, where they won't log errors and they won't deny requests. They'll let it happen just like they did before in the old system, let's say, but they'll log everything, and then they'll report back saying, okay, this person attempted to try and log on to that web app where they weren't authorized, but they had a valid username and password. I don't know if you just you messed up, you forgot them in the policies, but we're just flagging it, sort of thing. And so you kind of use this in kind of a monitoring phase where you kind of detect all the access patterns and all the resources that you didn't account for originally because you missed them or forgot about them or something like that. And then you can go back and kind of further refine that. So that's like the initial rollout will always be kind of fraught with problems, because people who originally had access to these resources that may have been used or may have been used infrequently, think of like a quarterly audit or something like that. They may have been lost in the policy. They may have been denied authorization when they should have had it, because they only needed it once every 3 months. Those kind of things will obviously kind of bubble up as zero trust is rolled out. A lot of the multi-factor will always be a rocky road, because people will lose, their second factor. They'll lose their cell phones. They'll lose tokens, smart cards, things like that. That always happens. And if you lose one, then you're kind of locked out of a lot until that second factor is replaced, or there has to be some sort of mitigating policies in place to let people continue on with their work until they can get that, that either that cell phone replaced or smart token or something like that. Again, those kind of operational things. I mean, anytime you add more security to things, unfortunately, you also add a little more fragility, because that's, in a way, you kind of want that. You want it to break. You want to deny those requests, because you don't know if it's an attack or not. But often zero trust, it's block first and then go back and say, well, wait a minute, was that actually valid and something just went wrong, or not? And that's, unfortunately, it's probably going to happen, on the initial rocky road to deployment in a lot of enterprises. But that unfortunately, that kind of almost always happens. And the idea is to kind of make that as smooth as possible, either by monitoring, having administrators trained, having help desk trained, and things like that.
Thanks. Yeah, totally understand. Yeah. So next question is, will zero trust integrate with the existing or legacy technology?
We get that question a lot. The answer is depends, but probably not. I mean, it's one of those where, depending on what the capabilities of that legacy technology is, may or may not. And if it can't, there's sometimes some kind of mitigating things that can be done, kind of, let's say, upstream of that access. I mean, for example, we've seen some some discussions of like some architectures laid out where they'll have a legacy system, but it's actually made up of multiple, of like a web front end and then a database and things like that. So what they end up doing, saying that even though that's technically 3 different resources, it's kind of lumped together into one enclave, and they'll put a gateway in front of it. So once the initial access goes through that gateway to like the web front end, technically they may be able to reach the stuff in the back to the database or something else, because they're all in the same kind of enclave. Maybe not, depending on how you can set it up. But the idea is that at least those 3 components that need to talk to each other in order to perform the business process is kind of segmented away together from everything else. So you kind of do like these, instead of kind of a micro segmentation, it's a little more macro. But at least you're kind of segmenting away, kind of individual little enclaves. So that's better than, having it all in an open LAN or something like that. So it's those kind of things. Or we've seen for some like kind of legacy IoT that even things like printers, there's been some people like making and producing, some companies produce like these kind of little boxes that kind of acts as a reverse proxy, and they can do encryption and even some authentication if they need to, and kind of are a little more, they're like kind of like mini smart firewalls that you can put in front of like IoT and things like that. So while you may not be able to actually manage those legacy endpoints and resources, sometimes you can do a little bit upstream to at least get some benefits come from more of a zero trust architecture and make them at least still being able to be operable for a while, or at least meet some of the principles. So while not ideal, there's usually some ways to kind of work around kind of legacy devices, and kind of like maybe by approaching it kind of an upstream thing.
Thanks, Scott. This question, I think it will take you an hour to explain, but maybe just in 1-2 minutes. So the question says, what is the major issue you have faced while implementing the zero trust at your place, or maybe at some other place? So they just want to know your experience about implementation.
Well, I mean, practical. Unfortunately, the thing is always money. You don't have enough money to rip and replace everything. and train everybody in it. I think it's been, kind of the people. It's, the risk analysis, determining, what is actually the vital mission, what is the actual risks associated with it, and then can we actually set policies on that? And then once we do, what are kind of like the low-hanging fruit that we could do? With a lot of it is now identity based and things like that. So that's kind of like the approach that a lot of agencies are taking first, is this enhanced identity governance, kind of like saying, at least can we get multi-factor in? Can we get more phishing resistant, authentication mechanisms instead of just plain username and password? The idea is that if we can stop phishing, we'll stop at least the attacker from getting that kind of foothold in. And so, those kind of things of saying, like, can we modernize a lot of our identity stores and things like that? So a lot of it is identifying the moving components, that what needs to be upgraded in order to get something like an enhanced identity governance approach and things like that. That always seems to be like the biggest hurdle, because once you know that, then you can actually make a plan and kind of deploy things. But it's often just identifying everything. What are all the moving components that will be impacted once you try to make this kind of change?
Thanks. We don't have much time, but the last question says, is there any certification available for zero trust architecture?
Hold on. I was about to say no, but I believe it's either Gartner or Forrester. One of them has kind of a certification approach for like zero trust architects. And that was kind of developed by Dr. Chase Cunningham, who actually kind of did a lot of work in Forrester after John Kindervag left. So he kind of took over, inherited a lot of that work, and then progressed it even further. And they kind of created this kind of certification for architects and things like that. Admittedly, I haven't seen a lot of the material, so I can't vouch for it. It's not kind of an endorsement, but I do know that is the only kind of centric certification process that's specifically geared towards zero trust in a general sense. Now, every vendor may have their own kind of certification for their platforms, but this is kind of more of a general architecture.
Question, I think I cannot miss this one, so sorry, but I will ask this one. It says, how does an organization become a zero trust enterprise?
The simple answer is if they start working off of a zero trust architecture. If they're in that process of kind of migrating to a zero trust architecture, they're planning, they're deploying, they're using these principles, then we usually refer to them as a zero trust enterprise. Saying that they're using a zero trust architecture.
Right. So with this, now I will invite my dean to conclude this session and formally thank the speaker, please.
Yes, thanks, Professor Nasrullah, for the excellent moderation of this session. I would like to thank Dr. Scott Rose for the excellent and sharing of his experience and introducing the zero trust architecture as one of the pioneers in this field. I believe the Saudi Aramco Cybersecurity Chair have a focus in the zero trust, and today's session contributed to our focus, and I believe we'll collaborate with you, Dr. Rose, to see how we can do more research in this area. And I would like to thank also the audience for their engagement, their participation, and I'm sure they have benefited a lot from this session. So on behalf of the Saudi Aramco Cybersecurity Chair, thank you, Dr. Scott.
Thank you for having me. And there was a lot of good questions.
Thanks a lot. Really appreciate it. And thanks everyone.
Thank you.
Bye.